So this question has been asked in NIMCET 2009. I'll read it out for you first. In the virtual memory system, the address space specified by the address lines of the CPU must be blank than the physical memory size and blank than the secondary storage size. If you want, you can pause the video for a second and read the question by yourself. I'll directly go to the explanation part. Now, in order to solve this question, we need to understand a few terms first. The first term is virtual memory system. Virtual memory system. So what is the virtual memory system? Virtual memory system is the concept that was adopted when the size of processes would be much larger than that of physical memory. Now, in earlier times when memory devices were not so advanced like they are today, like 8 GB of RAM is quite common in our times, but in earlier times what used to be was generally we would not have so much of memory at our disposal, and it would happen in many cases that the size of a process is much greater than the size of our physical memory. Now, in order to be able to run such processes, the virtual memory concept was developed, which allowed processes to be larger than that of physical memory. So that is what is meant by virtual memory system, when we allow processes to be larger than that of the physical memory. Although in today's times we wouldn't find a single process which would compete with the size of our main memory. However, the initial motivation for introducing virtual memory system was as I mentioned. Okay, now coming back to the next keyword, the address space specified by the address lines of the CPU. Now, what do you mean by the address space specified by the CPU? The address space specified by the CPU. Now, the address space specified by the CPU is the logical address. So, generally we'll have two types of addresses. We'll have the CPU will generate something known as the logical address. Now, from the logical address, what we get is the logical address space. The logical address space. Now, what is this logical address space is? This logical address space is nothing but the size of the process. So, the CPU will generate a logical address from which we can derive the logical address space, which is nothing but the size of the process. Now, in virtual memory system, as I mentioned, that the size of the process, now here they've said must be, since the initial motivation for introducing virtual memory was that the processes have to be much larger than that of physical memory. That's why they've used the word must. Otherwise, in today's times, you wouldn't have any process that would be competing against the size of a RAM. Anyway, so the address lines, the address space specified by the address lines of the CPU must be blank than the physical memory size. So this must be greater, right? Must be greater than the physical memory size, and the blank than the secondary storage size. Now you might be wondering that a process can be larger than the physical memory. Okay, so we are pretty sure about the lower bound, but what about the upper bound? Can anything be infinite? Infinite has no practical existence. So although virtual memory system allows or gives the user an illusion of infinite memory, that is not the case. By infinite memory, what you mean is the user gets an illusion that you can run a process of any size, but which is constrained by the size of your secondary storage. Of course, a process cannot be infinite. In practical sense, there is nothing such as an infinite process. Everything has a limit to it, especially if you are going to represent it using machines. It is a practical concept, not a theoretical concept. So that's why in order to represent processes, we'll also have to specify an upper bound, and this upper bound is specified by our secondary storage. So it must be greater than the physical memory size and it must be lesser. It must be lesser than the secondary storage size. So this is the answer. It must be greater than the physical memory size. So a size of a process must be greater than the physical memory size if you are using virtual memory system, and it must be lesser than the secondary storage size. It must be limited by the size of your secondary memory. Otherwise, the process will not be able to run. If you have a process which is greater than the size of the secondary storage as well, then you will not be able to run it even with the virtual memory system. I hope this explanation is clear. Thank you.